My 2020 late New Year resolution is to build a wildlife camera with a Raspberry Pi, Python, a camera, TensorFlow, OpenCV, and who knows what else. It's going to be an awesome camera, but first I have to set up a development environment to work with. That is why today I'm going to be creating my Git repository on GitHub, setting up TensorFlow on a Raspberry Pi, and I'll be using Docker on the Pi because that is an amazing container framework. An AI without TensorFlow is like football without a ball.
Wow! Reminiscent of the rune of...
I know that PyTorch is more Pythonic than TensorFlow, but I'm not ready yet to try something new. Hold on to your beer, get your popcorns ready, cancel your Netflix subscription, you'll have no time for it, and get ready for a thriller. This is going to get exciting. Setting up TensorFlow on a Pi, not TensorFlow Lite. The full TensorFlow, 100% TensorFlow. We will be resolving compile errors, installing missing libraries, resolving cross dependencies between libraries, searching for answers on Stack Overflow, waiting hours on end for something to compile. And then having to do it again and again and again. And finally, before you know it, the dogs are sleeping, the owls are resting, the lions are feasting. But we are still awake trying to figure out those build errors. Get some coffee if you run out of beer, because things are going to get serious. But we will get it done. What are you waiting for? Let's get started. So I have here a Raspberry Pi. It's quite cool, it's transparent. Because it has green, that's cool. You won't see the green, you'll see transparent. But I promise you this is a Raspberry Pi. Right, so let's find TensorFlow Raspberry Pi. I think TensorFlow used to have some images for Raspberry Pi for the ARM processor. But I don't want to build it from source, it will take a couple of hours for sure. But there is already a TensorFlow image with Docker. So I'm following the TensorFlow guide here. So we kind of left for a second camera. It's running, no problem. Just that I need to start thinking about the different components for this project. I'm just setting up the basis for later on to make things easy for me. So I need a Docker container with TensorFlow, with Python and an OpenCV. And we need probably an OpenCV with lots of options in terms of drivers it supports and so on. But let's follow this guide. Install Docker. So it's telling me to download TensorFlow, checking out the branch. I guess it will be a release branch, a stable one. I remember having some Docker images already ready to go. So let's have a look at the Docker images that are already ready to go. So we don't have to waste time compiling TensorFlow in a Raspberry Pi, which can take an hour or two. So I need to look at the images that I have available here. Most of these images are going to be for AMD 64. That would be compatible with x86, but if I want to actually try on the Raspberry Pi, it should have ARM, which is the type of processor. Oh my. So there's no ARM option here. If TensorFlow doesn't have an image for ARM architecture, I have two options. Look for someone who has done this in the past. I've done it for another version of TensorFlow, or build another Docker image for TensorFlow. I'm not sure. There's a TensorFlow Lite which is specific to the Raspberry Pi. But I've run Raspberry Pi, the full version, before. Maybe I have no choice. So I'm going to create a new repository. I'm going to call it Raspberry Pi Docker TensorFlow OpenCV. Okay, so it should be good enough. Oh, it seems like I have two threads open. Oh no, the one it was VLC, it doesn't matter. I'm going to do something else for now. So I know I'm going to get an error. Oh no, it worked. So I'm going to create a new Docker file. So just find my projects in the past, see what I've done. Oh yeah, I have a good example. I did a smart lamp that can tell you the weather in the morning, and I created a Docker file for that. And it was quite handy because this Docker file starts with this. It already has Python and it has the libraries I need. So the Docker images that you choose, they need to be compatible with ARM if you're trying to run it on a Raspberry Pi. I think I need to integrate my IDE. I'm going to also copy the Docker Compose as a starting point. Okay, so I'm just going to change the service name. I'm going to call it camera for now until I have a better name. So now, so if I try to do Docker Compose, by the way, I should have another Docker running in my, sudo Docker. But I already have a Docker container running. This is a Docker container I set up to get the weather information and then change the light based on the weather. It's quite a cool project. I also have a YouTube video that you can check out on my channel. Anyway, so I'm going to try and just get this Docker container to start without doing anything for now. I think I need to sudo again. Okay, so I need to build first. Okay, I'm going to make sure my user has permissions for Docker, so bear with me. So I'm going to go and find out how to add it. There's a setup for that. So, what I need to do, I've already installed Docker. I'm just making sure, okay, I want this. So I don't have to be bothered again to call sudo whenever I do something with Docker Compose. I need to exit and start again. So Docker ps-a permission denied. So what's missing? Seems like I'm still not part of the group. Okay, I might have to figure this out later. It's just a small annoyance. The Docker, so if I do sudo docker ps-a, it works. I already have the container running for some reason. It's failing with an error. Let's see what's going on. So in the camera, again with the sudo, I kind of keep restarting. It doesn't do anything. So I didn't really put any instructions to call anything. So I can do one thing, which is I'm going to do a tail. Okay, so Docker Compose couldn't connect. Okay, so let's see if now when I start Docker again, it will stay up. So I'm starting the container again, the camera container. If I'm lucky, it's still up and running, yeah? Oh, I forgot to add the -f. -f means to actually wait, basically. -f is to keep checking the file. Now it should work. You shouldn't just exit. I just want to have the container up and running because it can be useful to check what's inside and what's not. Okay, so as you can see, it's up now. I can actually go inside the camera, inside the container, and check what's inside with the Docker exec. Okay, so I'm already inside the container. It has Python 3 already set up, and what I want to do is to try and follow those instructions to basically just add everything that's needed. Just going to copy and paste this stuff here. A virtual environment in Python is almost like a separate zone that you can do things and without worrying about any other libraries that are installed in your environment, in your operating system. But because I'm using a Docker container, that's kind of the same thing, so I don't need to create a virtual environment. So I'm just going to follow these steps here. So installing a bunch of stuff, which I'm not 100% sure it's actually needed. What I really want is TensorFlow. Well, let's go with version 2.3.0. Copy link address. Wait, the assets. So I need to use the right architecture. I think ARM7L is the correct one. Yeah. I don't have TensorFlow as far as I know. I don't need to uninstall what I don't have. Okay, just need to copy. Let's see if this works. So I'm just going to do a build of the Docker file again. Oh, don't need sudos. I don't even know if apt-get is something I can use within the container. Let's find out. Oh, more sudos. So actually each command in Docker needs to be preceded. If you want to run something in the shell, you have to use run, and I forgot to do that. pip3 should install what I need. So let's try that on its own. I'm going to comment out all the other lines for now. It's okay. I don't know how to comment out. I'm just going to do a build. I don't know if those libraries are actually needed. Okay. Basically, sometimes if you don't update your apt-get command, it will have out-of-date repository references. So you need to do this. I think that's there. So I update first, then I can download anything I want. Okay? So it's installing, hopefully TensorFlow. It's installing Keras. I don't think it's needed, but I copied and pasted everything for now. I don't even know what these libraries are for. So there are dependencies. Okay. So I'm just waiting for this to complete. Okay. So failed. You know when things fail, things are going according to plan. So I'm getting an error. I don't know what the error is just yet. So this step here failed. So H5 EY. I don't even know what that is, honestly. I need to check it out. Wow. So I'm getting an error. It's just a mile long. To be honest, I don't even know if this library is really needed. I would hope it not. Then I don't have to spend time figuring out what it does. Let's see what this is. Am I going the wrong way? Am I doing the hard way? So this is another guide for installing TensorFlow 2 on a Pi, right? It does have official packages, so why am I doing here? I'm just trying to build something that I don't need to build. I looked earlier at the Docker containers that TensorFlow releases. I couldn't find any Docker container already set up for the Raspberry Pi, so I'm a bit confused, honestly. But I could just do this and see what happens, and skip that horrible error. Camera, bash. I'm just going to try and install it here directly and see what happens. I wanted to install version 2. If it installs version 2, I'm very happy. There's no requirements that satisfies install upgrade minus pip. So let's hope that upgrading pip actually helps. I don't see how it can, but it does say in the documentation you should have the latest version of pip, but it doesn't have. Okay, so I'm downloading TensorFlow and see if I'm lucky with the installation, whether it actually requires any of the prerequisites. The documentation is not very clear, so I'm a bit stuck with the Docker and TensorFlow. I know from the start this is the hardest step. So the Raspberry Pi 4 is giving me a headache. TensorFlow 2, Raspberry Pi 4. It seems like someone managed to create an image already for TensorFlow. It's a bit out of date, but if I can find the Docker file, that'd be nice. So maybe I try this one. Nice. Empty lines everywhere. So I can just replace this URL with the latest version of TensorFlow. So I'm just going to copy this URL. Hopefully it will work. Okay, let's try. This might take a while if it goes well, or fail quite quickly. So yesterday when I was also doing some programming, I had an eagle show up in my window. It's not really an eagle, it's called a sparrowhawk. If I had my wildlife camera already ready to go, I would be able to take a video clip out of it. I'm going to show you the picture. So I never had that type of bird show up at my window and my roof. So do you see this? This is a sparrowhawk. I live in London. Apparently they are not uncommon in the UK, but trust me, the thing I see the most around here is a pigeon. They normally come quite often here, but this is a special bird. So if I had the wildlife camera ready, I would have been able to capture it. Well, I took a picture of it, I was lucky, but you know, a video clip is much better. And who knows, I've only noticed the bird here once, but maybe it comes quite often. I'm still waiting for my compilation to finish. I'm still installing TensorFlow. It's taking a while. Maybe I can switch on the camera in the meantime. Again, Raspberry Vid. Let's see. Might not be a good idea because I'll just do it for a second, but I don't want to slow down the process of installing TensorFlow even more. But just to give you a start VLC. So I opened just now a live stream from my camera, my Raspberry Pi camera, which is now open. It's the RTSP stream. It's a bit of a lag, but not too much. See? I'll say hi. It's a bit out of focus because I had to remove the lens from the camera, and I don't think I've managed to focus it too well yet. So waiting. The next thing, I guess we can check. The next step would be to run OpenCV. I don't know if you heard about OpenCV or not, but OpenCV is a fantastic framework for manipulating video. If you ever study computer vision, you'll come across OpenCV for sure. It's the thing that you must learn, and we're going to use this in the project. Another fun thing is going to be to try and install OpenCV in a Raspberry Pi. So right now I'm just setting up all the environment, the development setup, still working within the terminal. Because I prefer to develop in my own local computer, I'm going to set up a synchronization of source code between my computer and the Raspberry Pi. There's quite a few steps to go through before I actually start doing the thing that is most fun, which is actually writing the source code. Okay, so installed one more package. It's getting there. 9 out of 14 now. So it's installing some other packages. Just to give you an idea, I'm actually creating a Docker container that I can use later on for development, because I'll be using TensorFlow, OpenCV, Python of course, so I need to have a container which has everything I need. And by the way, you can see here this very lousy image. It's the camera, the worst camera I have, because this is going to be a wildlife camera, so I need to be serious about the camera. I have another camera which is actually anyway, I have better cameras here. They actually have an Ethernet cable, but with an Ethernet cable I can actually connect it to the Raspberry Pi. I can have any camera I want with good capabilities, with good image processing. And the idea of having the Raspberry Pi is I can apply some AI, object detection, outside of the camera, but so I can detect whatever I want. In this case I want to detect cats. I could also detect birds if I want to. Eventually I'll use a camera like this one. Or there's another option. Raspberry Pi has launched a new camera called the Raspberry Pi Camera HQ, but I find it a little bit expensive. It's like this is just for the board, costs you £50, and then if you actually want the lens, there's another £50, so it costs you £100. But it's a much better camera than the one I'm using right now. But I think these cameras I have are even better. Well, especially this one. It's a small camera, but it has a low light sensor, so you can actually record in true color at night. Alright, so it's now installing TensorFlow. What I want to do is actually publish this image into Docker so that I don't have to always build it again. As you can tell, it takes like an hour or something to just build this. So if I want to be a good Samaritan for anyone else who's trying to do the same as me, I would publish that into the Docker Hub. And I'm going to do so. Okay, let me just have a look at this Docker file. I'm going to publish this Docker file so that I don't have to do this ever again. I can just download the Docker file and I'm done with it. So how do I do that? I need to go into my Docker account, which I'm not going to share in public. The way it works, you get a free account in hub.docker.com. You can create a repository, and I already created once TensorFlow. Let me see, TensorFlow. So I have created in the past a few packages for TensorFlow. I'm going to create a new one. TensorFlow 2, Raspberry Pi 4. So I can do a Docker push. So basically the command is this one. I need to use sudo for now. And I'm going to try and use the actual version number here, so I identify which version number I'm using. So I'm pushing the image I have created. Of course I always need to put sudo for now. Because I'm renaming the image. I need to figure out how to actually rename the image. It shouldn't affect anything because I've already built. Let's see if this works. Seems like it worked. So it's now uploading the image to the repository. All right.